Let's actually begin to code with iterators and get used to actually using them in some code. So in the last video, I just drew out some things on a paint type program and just showed you sort of how you're going to use iterators. But let's actually look at some code. So I'll create a new project. I'm going to make an empty C++ project. And then I'll add a source file. We'll just add a main.cpp as usual. And then let's put in our normal stuff. So I'll make this a little bit bigger. So we're going to include IOStream. So we're going to include string. May or may not use it. Let's include our vector. I know we're going to use vector. Let's include list in case we have time to use our list. Standard namespace. Okay, so let's make sure this works. Say 28. Okay, that'll be good now. Okay, so let's create a vector. Remember, don't forget a vector is basically our dynamic array. So we're going to say a vector, and we'll just use integers because they're pretty easy to work with. We'll say my vect, and then let's add some things. We'll say my vect dot pushback. We're going to add a 5, and then let's just add a few of these. 4 should be good enough. 2, 18, 31. Okay. So now let's use our iterator. So now think back to our memory model. We have some area of contiguous memory, and then we've got 4 integers, and we could print out the memory addresses, and we could get kind of fancy with that. But let's use iterators. So we're going to say I'm sorry. So now we're going to can't forget to. So we have to actually declare that we're using declare an iterator variable. So we're going to say vector of int, and then we're going to use this syntax. Don't worry about what this is really. And so you can see this is, we have our iterator, and we'll just call it iter for now. Okay, let me increase the size of that so you can see that really big. This is the syntax to declare an iterator. It gets a little tricky, so I want to make it really big so you don't miss anything. These are colons. You've got your normal semicolon at the end of the line. You've got your angle brackets. Okay, I'm going to make this smaller again. It should be enough to fit on your screen. Let's go one smaller. Okay. So now the reason we do this is because we typically want to use it in a for loop. And so I'm going to write a big long for loop, and then I'll tell you what it means in a second. Okay, and what I'll do is, I hope I don't confuse you too much. I'm going to put these actually on separate lines, but this does not change in any way the for loop. Don't forget that's a feature of C++, and I'll make it a little bit bigger so I can explain it. Make sure I have everything on the screen here. Okay, pause the video if you need. Make sure you have all this typed in correctly, and let's make sure we can actually click the play button. So we didn't get any compiler errors, so that's good. So pause it if you need to type this into your Visual Studio. Okay, so what's going on here? So we've declared an iterator, and our iterator is some magic that happens in the background. It knows how to move through our data structure, our vector in this case. And so we're saying the iterator, we're going to set it to the beginning of the vector. And so remember our memory diagram, what happens when we call this myVec.begin, it's giving us the beginning of it. And then we have while the iterator is not equal to the end, and so we're saying while we haven't traversed the whole thing, while we haven't gone through the entire vector, then we're going to do iter plus plus, and that gives us the next element. And we're using vectors now, but that could have just as easily applied to lists. Okay, so how do we actually to use this? Well, it turns out that the iterator is going to be basically a pointer to our data type. So what we can do is I'll just say value is, and then we use our dereference operator, and so we're going to say star, and then we're going to say iter. So that's how you dereference it. And as you can see, 5/2/1931. So again, pause it, really think about what's going on here, really understand what's actually happened here. So when we want to get the value of it, iterator, it's actually a pointer to a memory slice, and so as we go through this, as we move our iterator along, it's actually giving us memory addresses, and then so we could actually, this should, well, I'm gonna take a gamble here. Let's see if this works. It may not. I don't know if we can just print the. Looks like it's not going to. And I'm not going to fool with it. But we could, if we wanted to figure out all the syntax and everything that's returned, we could actually print the actual individual memory addresses. So don't forget, this stuff is always stored in memory, but the iterator does a lot of overloading and it does a lot of C++ magic, so we don't want to worry about that too much. We just want to know that that's sort of a thing that happens, but let's make sure we still have working code. Okay, so I'm going to make this smaller. Let's go ahead and let's just as easily change this from a vector to a list. So now we're, instead of a vector, we're going to say this is a list. So everywhere, let's go ahead and did we include list? We did. So okay, so this should work. So we're going to say a list, and then instead of myVect, let's give it a nicer name. Let's say my list. Iterator doesn't need to change. And then we're just going to say my list. So now we have a linked list instead of a vector. Change this. And that should do it. So as you can see, these are pretty interchangeable because all we really did was change the type. And don't forget that this list is a class, so we could go through Visual Studio source code and find list, a class called list somewhere, and it would have methods and internal variables, and it would have public and private variables, and so never forget that what's really going on is all this stuff is classes. And we interchangeably use the pushback. So when we use the pushback, it's putting it to the end of the list. Previously, it was the end of the vector. And so this iterator, we're saying we know the beginning of the list, we know the end of the list, and so what we're doing is we're testing. We're saying we're setting it to the beginning of the list, and we're saying while we're not at the end of the list, go to the next part of the iterator, and the iterator knows how to go through all this stuff. As you can see, it's a part of the list. And then we dereference it, and we actually print out the value. And then you can see that we've actually printed out these values. So hopefully iterators make a little bit more sense. I know they can be a little confusing. Even if you don't understand all the internals, just understand that it's the thing you use to actually go through your list or vector when you want to get each individual item of it, and type this all out. Make sure you have some proficiency at getting all these things under your fingers and knowing the angle brackets and the and the colons and all these other little syntactic things. And never forget that this is a very C++ and STL specific topic. So so if you move on to another programming language, they may or may not have some equivalent of iterators. Depending on the language and the design of it, they may not actually even need these sorts of things if it's a programming language that pretty much manages and handles all the memory so that you don't even have to know how to move through memory.